Hello everyone, welcome back to the channel. This is Mr. Sam, and in this video we'll be doing physics. We're discussing some exam questions that can come out under the topic work, energy and power. Now before I go into the calculations proper, I'd like to quickly summarize the formulas for work, energy and power. Starting with work, we know that work is said to be done when a force acts on a body, causing it to move through a distance. So the product of the force and the distance is work. And now F is equal to MA, that is force. You can say work I'm gotten by saying M times K times S. Now the energy that is discussed under this topic is mechanical energy, which is divided into two. We have potential energy and kinetic energy. Potential energy is simply mgh, the mass times acceleration to gravity times the height, and potential kinetic energy is half mv squared, where v is the velocity of the body. So kinetic energy is simply energy possessed by a body in motion. Potential energy is the energy possessed by a body by virtue of its position, mostly at rest or at the height from the ground. While power is work done over time taken. You can put in the formulas for work to get different formulas for power. You can say force times distance over time. Distance over time is speed. You can represent that velocity and say force times velocity. You can also say F is ma, so that is m times a times s over time. We can also say, since we can use mgh for finding work, and this is simply because work is measured in joules, energy is also measured in joules. We can use their formula for each other. And these three things are the same as this, only that acceleration is linear here. This one is acceleration to gravity, vertical. This is linear or horizontal distance, and the h here is vertical height. So when it comes to a body going up or coming down, the work done there is calculated using mgh, where g is a constant value, which is approximately 10 meters per second square. So these are just a few things that you should take note of. Then if we can use mgh for work, this will be mgh over t. So all these are different ways or formulas that we can use under this topic. So we'll get right into the calculation now, since I've done that small summary. We'll start with number one. The question says a 40 kilograms girl, so that is the mass of the girl, 40 kg. Mind you, if it's not in kilograms, we have to convert to kilograms. If it's in grams, you divide by 1000 to convert to kilograms. Climbing a flight of stairs expends energy. So this girl is going up. Whenever somebody is going up or coming down, it actually always involves g, acceleration to gravity, which is 10 meters per second square. She expends energy at the rate of 50 watts. Rate of 50 watts. What is the rate for power? I did say that earlier. So this is basically power, 50 watts. The time taken for her to reach a height of 20 meters is, so we're giving a height of 20 meters and we're looking for the time taken to reach that height. So basically we're going to, since we're talking about power, we use formula for power. We know power is work over time. And we have mgh, so we're using mgh over time. What we're looking for here is time. Power is 50. The mass is 40, G is 10, H is 20, all over time. So if I cross multiply, 50 times T is 50T, and if you multiply all this, you have 8,000. When we divide both sides by 50, our time will be equal to, this divided by this should give us 160 seconds. So the answer to the question is D. I hope that was clear. Now let's move to the next question. An engine develops a power of 750 watts. By giving power of 750 watts while moving a car at constant velocity. Again, the velocity of the car to be 3 meters per second. Come on, say the force exerted on the car by the engine is, the force is, we know that power is force times velocity. So the force is what we're looking for. When the power is 750, you can find force, the velocity is 3. So we can divide both sides by 3, and we shall have our force as 250 Newton. The answer to that question is B. I hope that is also clear. Now, number 3 says a car of mass 800 kg initially at rest is accelerated at the rate of 4 meters per second square. So let's write out the values already. Mass is 800 kilograms. It's accelerating at a rate of 4 meters per second square. We want to say we should calculate the kinetic energy of the car after 5 seconds. Give us time for 5 seconds. Say find the kinetic energy. We know the formula for kinetic energy is half mv squared. We have the mass, but we don't know the velocity of the body. But we're given acceleration and time. So here we have to make use of our knowledge of the equation of motion. The first equation of motion here, it states that v is equal to u plus at. So using this, we can find v. It's accelerated from rest, and when it's from rest, u is equal to 0. Acceleration is 4 meters per second square. The time is 5 seconds. Using these details, we can find v now. So we can say v is equal to u0 plus a4 times t5. So 4 times 5 is 20 plus 0. Our v is 20 meters per second. Now that we have v and we have our mass, we can put it inside this formula and we can find our kinetic energy. So kinetic energy is half mv squared, and that is half times 800 times v squared. That is 20 squared. That's 20 times 20. Half of 800 is 400. So we have 400 times 20 times 20 is 400. 4 times 4 is 16 with 4 zeros. And if you take this to standard form, that should be 1.6 times 10 to the power 5 times energy, joules. Energy is measured in joules. So 1.6 times 10 to the power 5 joules. The answer is C. I hope that is clear. So I'll clear the body. I'll go to another question. So here are the questions that follow. Number 4. An object of mass 12 kg is held at a height of 5 meters above the ground for 30 seconds. The question says we should find the work done within this period. Now, questions like this are used to test your knowledge of the topic. Let's say this is the object of mass 12 kg. You hold it at the height of 5 meters. You can measure, but let's assume there is a height of 5 meters here for 30 seconds. So just stand there and hold it for 30 seconds. The question is, what is the work done? Our knowledge of work is that work is done when force moves a body through a distance. If no distance is covered, then no work is done. In this question, the answer is 0. And the reason is, the body was just held at a certain height. It did not go up or down or move forward or backward. So the answer here is 0. It's just a test of your knowledge. The next question. An object of mass 20 kg is released from a height of 10 meters above the ground. The mass is 20 kg. The height above the ground is 10 meters. We should calculate the kinetic energy of the body of the object just before hitting the ground. Here, we also have to apply knowledge here. When an object is at a height from the ground, let's assume this is the ground. The height in this case is 10 meters. They give us the mass, whatever. So when it is at this height here, at rest, before being released, it has potential energy. In fact, it has maximum potential energy. And to calculate that maximum potential energy, we use mgh. Now, the moment it is released, it starts coming down. It is moving now. The potential energy will be decreasing simply because the height above the ground is decreasing. The mass remains constant. So as the height is decreasing, potential energy will decrease. But this is the beautiful thing about potential energy and kinetic energy. As the potential energy is decreasing, kinetic energy is increasing. At this point here, where it is at rest, kinetic energy is 0. At the point here, just before hitting the ground, the kinetic energy will be maximum here, while potential energy there will be 0 because it has attained maximum speed before hitting the ground. According to the law of conservation of energy, energy can be converted from one form to another, but cannot be created. The energy that it has here is going to be constant throughout the motion, but potential energy and kinetic energy will both share the value. So the thing is, let's say the potential energy here is 1000 joules. At this point, it might have dropped to say, let's say at this point, it is 300 joules. And the kinetic energy should be taking the remaining 700 joules, because at every point, they must still sum up to give that 1000. At this last point here, the end here, kinetic energy will be maximum and it should have the same value that you have up here as potential energy, while potential energy will be 0. So using this knowledge, we can simply say the kinetic energy of the object just before reaching the ground is the same thing as the potential energy before it was released. So we are going to be using mgh to find kinetic energy instead of half mv squared. So kinetic energy here is what we're looking for. We just say kinetic energy is mgh instead of half mv squared. So that is a 20 times 10 times 10. And that should be 2000 joules. And the answer is B. How would I explain? The next question. A 70 kilograms man ascends a flight of stairs. The mass of the man is 70 kg. He ascends a flight of stairs of height 4 meters in total in 7 seconds. That's the time, 7 seconds. The question says, what is the power expended by the man? Remember that power is work over time. In this case, it's going up a flight of stairs. So the work here will be mgh, where g is not given the question, but you're expected to know that g is 10 meters per second squared. So divided by time. So the mass 70 times g, 10 times the height 4, all over the time 7. 7 will go here 10 times, 10 times 7 times 4 should give us 400 watts. That is the answer to the question. That's it. So thank you very much for watching. This is how far we'll go in this video. You can find more questions, and if you have any question that's challenging, you could drop it in the comment section and I can make a video for you to explain it. Thank you for watching. See you in the next video.